Now, today we're going to actually begin part of what statistics is all about. Statistics is really about making the right conclusion based on information you have. But what we're going to do today, we're going to begin. We're not actually going to do a lot of stuff today. We're going to introduce vocab and how to set problems up, because if we don't have that, then the rest of the way won't make a lot of sense. We're going to do what is called hypothesis testing. For example, it would be something as simple as this. Roz claims that she's an 80% free throw shooter, or she's at least an 80% free throw shooter. And I go, wow, I've never seen you shoot a free throw. Do I have to just believe that? Or can I say to you, prove it? What do you think? Okay, so how would she prove it? She goes out and shoots a bunch of free throws. What the hypothesis testing is you have two situations. You have something that's going on, and then you have the complement of that thing. So in other words, either you are at least an 80% free throw shooter, or you're not. There's not a third option. Oh, either I can hit the bullseye, or I don't. There's not a third. Okay, either you're taller than this amount, or you're not. That means you're shorter than. Does that make sense? If you can break everything up into two things, you are or you aren't, then the hypothesis testing says, based on our sample, we can make a conclusion on which one you fall in. So where this is used really often in real life, we talked about this before. We have a bottling plant. You know, we fill up bottles of stuff, and the consistency may be a little bit off, right? We talked about that, man. So how do I know if it's time to replace the equipment? Well, I do lots of sampling. I look at my results, and I'll say, if my results are in a particular range, I feel okay. But if they're outside that range would be my confidence interval. If I'm outside that range, I say, you know what, it's too extreme. It's too extreme. Now, understand, everything's not absolute. Whenever you're doing sampling, is it possible you could get a bad sample? You did everything right and you still have a lousy sample. Yeah, so occasionally you can make the wrong conclusion, but the vast majority of the time, well, how do I know how often I make the right conclusion? Well, if you're talking a 95% confidence interval, you're going to make the right decision 95% of the time. Oh, because there's always room for the extremes. So what we're going to do is say, how do I set up any problem? So there's two things here. In hypothesis testing, a lot of people make the mistake of saying I'm testing a claim. Not necessarily. You have mathematical statements that involve equals and not equals, or greater thans and less thans. Okay. So what I want to remind us of, first of all, what are the complements? So here's what I have possible. I have, oops, let me get a different color for this. In here. I can have an equals. I can have a greater than. I can have a greater than or equal. I can have a less than. I can have a less than or equal. These are all the ways I can compare two numbers. They're equal, one's bigger, one's smaller. Now, the greater than or equal, less than or equal are important, because what are the words? The words are same or equal. This would be more than. What's greater than or equal? Perfect. That one always throws people, because the word least, you're always thinking the other direction. At least means I'm giving you the bottom line. I want at least 10 cookies if you want to pass the course. So 9 cookies won't cut it, will it? But 11 will. Yes. So at least 10 means 10 or more. So greater than or equal is at least. And even when I teach remedial algebra, it is absolutely imperative that we translate these words correctly. Otherwise, you do perfect mathematics and you'll always be on the opposite side. You'll always have the incorrect conclusion because you went the other direction. Now, less than is just less than. We know that one. And what's less than or equal? You must make less than or equal to 6 errors on your written test at the DMV. Less than or equal would be at most. At most. Oh, okay. At most would mean I'm giving you the highest you can do, and then must be less than. So if you can make at most 6 errors, then is 7 acceptable? No, but is 5 acceptable? Yes. So at most, at least and at most are the only two that people confuse, because they confuse most with more and least with less. That's not. At least, as I'm giving you the bottom line, it's that much. Okay, I'm giving you the smallest number it could possibly be, and then it has to be more. At most, I'm giving you the biggest it can possibly be, and then it has to be less. So first of all, I understand that these are translations. Now, what is the complement? You remember complement? Not my you look nice today, not that kind of compliment. Complement means everything else. So if we were talking about, if we were talking about dice, and I said, I want you to roll, the total of 2. Well, the complement would be every other roll on the dice. Complement is always everything else. So think about if I put the word not. So what's the complement of equals? That's easy.
With a slash.
Not equals. Oh, Roz says, I make exactly 80%, period. So that means she either makes 80% or she does not make 80%. By the way, if you make more or you make less, does that make sense? Oh, more or less. Okay. More than. More than. What's the complement of more than 10 in words? Would it be less than 10 or would it be 10 or less? If I said more than 10, wouldn't it be 10 or less? So the complement of more than is less than or equal. Oh, because the equal's got to fall somewhere, doesn't it? If I said, keep it simple, what's the complement of more than 10 cookies? Then you'd say less than 10 cookies, but then where does 10 cookies fall in? 10 cookies has no place to go, does it? Oh, the complement of more than 10 would be 10 or less. So on the driving test, the complement of making more than 6 errors would be exactly 6 errors or less. Remember when we talked about the mathematics of at least 1, and we found the easiest way to do it is calculate none? Because what's the complement of at least 1? None. What's the only thing left? Oh, so greater than or equal. At least 10 cookies. What's the complement? 10 or more. What's the complement? What's left? Think the number line. What's left? Wouldn't it be less than? Does that make sense? You bring me at least 10 cookies. What won't cut it? Less than 10 cookies. Not 10 or less. No, because 10 was already included in the first one. Now this should be easy based on the last two. What's the complement of less than? Greater than or equal. Greater than is more. Not greater than or more, no, greater than or equal. Do you notice that in each case, the equal falls here, the equal falls here, the equal falls here, there's always got to be an equal. Now, at most 10 cookies, what's the complement? In words. Always think words first. More than 10 cookies. So the complement of a less than must involve a greater than. Do you agree? The complement of a greater than must involve a less than. And I put the equals wherever, which side doesn't have an equal, the other side's got to get an equal. If I put these two together, well, you either made 80% or you did not. I've covered every possibility, didn't I? You either brought me more than 10 cookies or you brought me less than or equal to 10 cookies. That covers everything, doesn't it? You either brought me at least 10 cookies or you brought me less than 10 cookies. Okay, that covers everything. So if I understand the complement, then what we do with hypothesis testing, one of them, the other one. So one of them I'm going to test using whatever my sample is. I'm going to be vague and generic because there's so many ways we can look at this. One of them is going to be what I'm testing, and I'm either going to prove that thing or I'm not. And if I don't prove that thing, then what's my conclusion? Well, the other thing. Because there's only two outcomes. There's only two outcomes. It's this or it's this. If I'm starting with this, it's this or it's this. It's this or this. The situation dictates which one you're going to use. Does everybody understand? So if it's something like this, I'll use free throw shooting. So Roz says, I'm a pretty good free throw shooter. I make at least 80%. What you usually want to stay away from is saying, I make exactly 80%, because then if you make 90%, you're wrong. So wait a minute, I don't want to be wrong with 90%. Right? I have a restaurant and only 5% of the food ever gets sent back. And then we tested it and nobody sent back any food. Well, then you're lying to us. Wait a minute, but isn't that really good if nobody sends back food? Oh, so maybe we should say 5% or less gets sent back. Does that make sense? A lot of times we want to avoid this versus this, because if we're talking about quality, is it ever bad to be too good? In other words, you claim to be an 80% free throw shooter and you went out and shot and made 90%. I don't want to make it sound like you're wrong now, because no, you said you make at least 80%. That's pretty convincing evidence, isn't it? You say you make at least 80% and you went out and shot 50%. Now we'd say, you know what? You claimed to be at least 80%, but the evidence says you're on the other side. Then we would probably conclude the other side. Does that make sense? I want you guys to get kind of a mental thing, because in real life, we do this all the time. Now, I'm going to show you as we go. What we do with hypothesis testing basically is exactly how a court of law works, believe it or not. The whole legal system is based on the exact same type of logic. You are either guilty. Good. Innocent isn't an option, by the way. It is not guilty or innocent. Everybody would go to jail if those were the options. No, it's guilty or not guilty. Is innocent one outcome of not guilty? Yes. How about just if you're mostly guilty? Then you're still not guilty. What is guilty? 100%. Beyond reasonable doubt. Okay. Oh, so that's why we want to avoid this one. We really want to work with inequalities if we can, the less than's and greater than's, because, oh, okay. So in a court of law, you're guilty or you're not guilty, but not guilty could mean you're almost guilty. There's just not enough there to prove it, or you're completely innocent. Has anyone here, and this is important you understand, because I said the logic is the same, and we're going to see so many similarities over the next couple of weeks. Has anyone here ever served on a jury, or at least been part of the jury selection process? How far did you get? Oh, so no, then you haven't done jury. You don't get to do. No, I had like 5 years in a row, I think, where I served on a jury. It was awful. I mean, I got selected, I should say, but I didn't get selected because they're interviewing people. And when they got to me, I actually embarrassed both attorneys. Looked like idiots. I mean, there were two young girls who, one of them still had braces. One of them looked like she was in junior high. I mean, they literally looked like teenagers and they talked like teenagers. And I thought their client is going to die because the people, they were so unprofessional and they looked completely incompetent. And they would say things like, we're going to present evidence that might actually not be correct because the people, we don't actually know if it's going to be right. You're telling us this, that you're going to present stuff that may not actually be correct, that we're supposed to make a conclusion. And anyway, I was not pleased. But one of the things that happens, just so you know, nothing can go to trial. It's not possible in the United States for anything to go to trial unless there's already enough evidence to get a conviction. So you're arrested for something, you got the smoking gun and everything else, but when they start doing their research, they realize, you know what, we don't have enough evidence for a conviction. Therefore, there's not even going to bother doing a trial or pressing charges because they know they can't win. You only go to trial if they believe, if the law system believes there's a chance that you're a good chance you're going to be convicted. Now you go to trial and the defense attorney is going to try to convince the jury that there's not enough there. If you went to trial, you are guilty. You may not be 100% guilty, but you're still mostly guilty. It's the defense attorney's job to prove that you're not 100% guilty, create that reasonable doubt. I don't have absolute assurance they did it, so I have to vote not guilty. It can't come to trial unless you were mostly guilty. A lot of people don't realize that. That's why innocent is never an option. There is only one time that can happen, just so you know. You were falsely arrested. You were the wrong person. You know, one of those wrong places at the wrong time, you were arrested, they pressed everything. And then later on, you realize, okay, we made a mistake. Does anybody know what the word is in that case? And you can go your whole life without ever hearing of this. It's called exonerated. Exonerated means you should not have been charged. There was a mistake. And you're free, you are innocent. Any vets or any military folk? Military is interesting. There's no guilty and not guilty. In the military, it's guilty or innocent. They can't have not guilty. You're a commander of a ship and something bad happened under your watch and maybe you're going to trial. If everybody understands, not guilty just means you're mostly guilty. You just weren't all the way guilty. And I still have to command people underneath me. Are they going to trust me if I went to trial and all they found was not guilty? No, no, I have to be declared completely innocent or I'm going to lose all the people I serve. So the military is very different in that way. So it has to be guilty or innocent for them, because if you're not guilty, we need to go all the way. So if you're only mostly guilty, no, you're probably discharged. I've known people who were discharged honorably versus dishonorably, but something bad happened under their watch. They weren't innocent. They can't have a not guilty, because not guilty just says you're mostly guilty. Because again, you can't go to trial. So in a hypothesis test, we're always going to assume there's enough information there that could go either way. So we have to take our evidence. We have to take, what is our evidence? Our sample. And we take our sample and say, which side of the fence does the sample put us on? And that's not up to you. That's just the numbers. So you went out and shot free throws, you made 90% of them. Makes kind of an easy conclusion. So here's the tricky one. Roz goes out and shoots free throws. She said she's an 80% free throw shooter. She goes out and shoots free throws and makes 79%. Does that mean you're lying? You made 79%. You made 79 out of 100. One more, you get the 80. Is it possible you are absolutely correct that you're an 80% or better, but right now you just made 79 out of 100? Is that still okay? Yeah. Yeah, because the next time you might make 82 out of 100. So if you miss the mark by a little, does that mean that you were not telling the truth? Does that mean, no. Well, for me to say, no way, there's no way Roz is an 80% free throw shooter. What would I have to see? Something way less than 80%.
40.
Yeah, does that make sense? Why? Oh, okay. If you're that close to the mark, I'd say, yeah, that's reasonable that you are. You had a bad, 5 minutes from now, you might make 10 in a row. You'd have to miss the mark badly before I could say, no, you're definitely on the other side. So anytime there's a situation we're testing, it's not black and white absolute, there's a lot. No. The evidence says, is it very clear in one direction or is it a close call? And then we have ways of dealing with close calls. But what we really like extremes when we're testing to make our decisions easier. I want to see you make way more than 80% or way less than, I don't want to see you make close to 80% because that makes the decision making harder, doesn't it? In a court of law, boy, that evidence is so much evidence that I think they're guilty, but they could be, and then they deliberate and 11 people say guilty and one person says not guilty. So of course they're guilty, right? If 11 say guilty and one says not guilty when they vote, because there's always 12 jurors, what happens at that point? Does anyone know? It's called a mistrial. It has to be unanimous because we can't have the reasonable doubt. So the one person who said, you know what, there's not enough there. They're voting their conscience. They said there's not enough. Either that or they were paid off by the mob. We've seen enough movies. We know that's always, Joker was involved somehow or another, or the new Batman, there was a Riddler involved. And, aside from that, it has to be unanimous to get guilty because we can't have doubt. That one person might have been, the one person who said, I believe they're not guilty, might have been the only correct one in the group. But it has to be unanimous to be guilty. So if the one person said not guilty, then they have two choices. Either stop and let the person go or retrial. Now, here's the thing. They rarely retry. You know why? This is why this is perfect statistics. How is a jury selected in general? It's as random a sample as you can possibly get. You got a notice, and it's completely randomly generated by a computer. You got a notice, I got a notice, you didn't. Next time you got a notice, I didn't. Next time you got a notice. It's randomly selected. Everybody goes. And then what they do is they interview each person to see if you have bias. For example, I was in one situation where I believe it was a cop. A cop was shot. And this person already had been to jail. It was a 3 strikes case. And they were looking, this person was going to go to prison for the rest of their life if found guilty. And they had served twice on 2 really, really minor things, stupid teenage idiot stuff, like petty theft and stuff like that. But it doesn't matter. So this was now a situation where this person is looking at life in prison, and the judge says, you're going to see evidence where there was like an undercover cop and all this kind of stuff. And so the first things that the 2 attorneys, they will ask you questions to see if you're biased. So the first question they ask you, are you or is any member of your family on the police force? If you said, yes, my husband's on the police force, then thank you, ma'am, for your time. You're now dismissed. Do you think there's any chance they want you on the trial if it's about a cop shooting? No, you've already decided that person's guilty. That person's going to go to fry in prison. And by the way, whether it's right or not doesn't matter. You would be the most biased person on the jury because you're in a cop family. So that's the kind of questions they will ask. And if you said, no one in my family, do you have, they'll make maybe a couple historical questions that, if it's a drug case, they might say, do you have any history of drugs or is anybody in your family and blah, 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 blah. And you'll say, yeah, I have a family member who died of an overdose of drugs or got arrested, blah, 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 blah. So you have a bias now towards drugs, positive or negative, doesn't matter. One of the attorneys is going to say they don't want you. One of them does want you, by the way, really bad. If one of them wants you really bad, then you guarantee the other one doesn't. So the jury selection is kind of funny. You have to have no opinion, no joke. You have to have no opinion about anything. You have to be as bland as humanly possible. If you, well, you can get a lot of trouble for lying. I went to a situation where the judge said, or they're interviewing the jury, and they said it was, I don't even remember what it was. It was some theft. It was something. And the guy says, oh, I have an innate fear over this particular ethnicity because blah, blah, blah. He starts going on. The judge hits his gavel and goes, one more word, I'm going to hold you in contempt and you're going to look at 30 days in jail. Because if anybody else comes up with a dumbass decision to try to get out of being on the trial, you're going to jail for contempt. The judge knew right then, the guy's just making up a story to get off being on the jury. Yeah, you're getting a lot of, it was really obvious that he's, I'd be like, I'm afraid of women, it's something really idiotic like that. So I can't be unbiased because a woman is on trial. It was something that absurd. No, bad way to go. No, but if you said, it could be a situation where, let's say it's like a domestic violence case or something, and you have been a victim or you have family members that are, that's the kind of thing they want to know. Because they believe that it would be harder for you to be unbiased. I was on a hiring committee a few years ago. I hate being on hiring committees because that means for like a week or two, I'm sequestered. We literally, like a jury, we go to a room and all day we're interviewing people. We can't talk about it. That's the worst. We can't even talk about it. It's not like a court of law. This is we're interviewing people for a job, but we can't talk about it because there's several candidates. And before one of the interviews, one of the candidates who we were going to interview is actually a really good friend of mine. And the dean who was on running the committee, I said, Dean, I gotta tell you. I go, this person, we're actually very good friends. I said, do I need to excuse myself from this part of the interview? And then the dean says, are you capable of being unbiased? I said, absolutely. And the funny part is my good friend gave a terrible interview. So I wrote them off. I felt so terrible. They gave a really bad interview. And it was, and they came to me later and said, oh God, I'm so embarrassed. I did such a bad job. And I'm like, oh, yeah, you did. But the point was I said to the dean, I just want you to know, because if you tell me, no, you shouldn't be on this because you're biased, but the dean just said, are you capable of being unbiased in this process? And the dean thanked me for being honest and telling her ahead of time. But that wasn't somebody going to jail or not going to jail. That's somebody getting hired or not getting hired. And it turned out it didn't make any difference in the long run. But bias is something we all know can affect a decision. So right now we're looking at things, we really want black and white, no gray, because it's this or it's this. There can't be a third option. It's equal or it's not equal. There's no third option. So by the way, the situation dictates which one you're going to start with. Everybody understand? It's really easy. So if Roz is claiming to be at least an 80% free throw shooter, then aren't we starting with this? We're starting with, this is what Roz says. So what's the only other possibility? Yes. Oh, okay. So if Roz says she's at least an 80% free throw shooter, then either Roz is at least an 80% free throw shooter or she is less than an 80% free throw shooter. Does that make sense? Oh, okay. It's great. Okay. So there's two ways. I said it's hypothesis testing. So there's always two hypotheses. The one you go with or the other one, And so what the notation we use is as following. We have an H with a subscript of 0, and we have an H with a subscript of 1. This one is called the null hypothesis. I love that word. The null hypothesis. What makes it easy to remember, the null hypothesis is always the one that includes the equal sign. So given these two, this would be the null hypothesis. Given the next two, this would be the null hypothesis. Given the next two, this would be the null. The null hypothesis automatically is the one that includes the equal, because you can always measure an equal easily enough. The other one is called the alternative hypothesis. It's the everything else hypothesis. And in the end, we say one of these is what we're going to deem the truth, like a court of law. So in a court of law, what would the null hypothesis always be? But by the way, here's simple English. You start by assuming the null hypothesis is true, and then you let the evidence convince you that it's the other thing, or that it is true. You start with, I'm going to assume the null is true, and I'm going to let the evidence. So if Roz says she's a greater than or equal, I'm going to start with assuming this is true. And if the evidence is, like you said, you only shot 40%, then we say, no, this is the truth. We always start by assuming the null is true, and we let the evidence convince us otherwise. Does that sound simple enough? In a court of law, what is always the null hypothesis? You've been accused of a crime, you're going to court. What's the null hypothesis? We assume you are not guilty. No. We assumed you're guilty, we're already done. No, we assume you're not guilty, and we have to prove guilt, again, beyond a reasonable doubt. Oh, and if I can't do that, then you're not guilty. That's how it works. It's the exact same thing, absolutely same thing. In a court of law, the null hypothesis is you're not guilty. And then we have to prove your guilt. How do we prove your guilt? With the evidence, and testimonies and all that. And if you're not guilty, we should not be able to prove you are. Do you agree? That should not be possible. But if you are guilty, is it possible you can get off? You have a really good lawyer, and the other side didn't have a very good lawyer. Is there anybody on planet Earth that believes O.J. Simpson was innocent? You remember the O.J. trial? What a mockery of the whole justice system that was. And they got the biggest idiots in the world on the prosecution, and he got the best defense attorney. What was the guy's name? The slick Johnny Cochran. Is he dead now? They had the defense. The defense for O.J. Simpson was infinitely better and smarter than the prosecution. They were a bunch of knuckleheads. Yeah. And what should have been an easy, everybody on planet Earth knows, they got a not guilty plea. And what's so funny about that one, I don't know if you guys noticed, a few years later, he did an interview and/or book about, if I actually did do the murder, here's the way I would have done it. Do you remember that? If I did, it's like, it was his complete detailed step-by-step admission to how he killed all these people. And people said, oh yeah, if he did it, that's how he would have done it. No, that's how he did it. He's telling the world, this is how I did it. And the idiots let me get off the hook. It's like, oh my goodness. But the point being, an innocent person should never be found guilty. That should be impossible. But a guilty person can be found not guilty because we couldn't prove it beyond a reasonable doubt. Now, the reason we start by assuming not guilt, we want to make it hard to prove guilt. That way, if we come up with guilty, nobody's questioning, going, you know what? We didn't make it easy. Guilty people do get off all the time. Innocent people, it's extremely rare. It does happen, but it's extremely rare that an innocent person goes to jail. It's probably 1,000 times more common than a guilty person gets off the hook, because we just couldn't prove it. And by the way, as a society, we'd say, you know what, I'd far more err on the side of setting the guilty person free to avoid imprisoning an innocent person. Does that make sense? Because you'd say, we consider it an absolute tragedy when an innocent person is in prison, because of just, again, wrong place, wrong time. The evidence is, it's hard to imagine. I just saw something recently on the news. The woman basketball player, was Maya? She was like the greatest women's basketball player in the world just a couple of years ago. She won like high school championships. She won national championships in college. She won championships in the WNBA, was MVP and all this. And she left to become like a social justice person. And there was a man that she was aware of who had been imprisoned falsely. He'd been in prison, but basically life in prison for a crime he didn't commit. And she worked and worked and worked and worked and got the conviction overturned. You guys never, it's like one of the coolest stories I've ever heard. I just saw this last year. And by the way, they're married now. The guy had served, I don't know how many years in prison, was going to die in prison. And because that she just kept digging, and it was one of these, you know, kind of like in the deep South, you know, the racist jury, right? It was a bad movie. And they got the conviction overturned. This doesn't happen very often, but the world rejoices when something like that happens because like an innocent person set free. But the thing is, I don't believe there are a lot of innocent people in prison. I believe there are a lot of guilty people walking around because we want to make it hard on purpose. That way, when we come up with that decision of guilt. So in a hypothesis test, we actually intentionally make it hard to switch our decision. We start by assuming the null hypothesis is true, and the evidence needs to be overwhelming. You like football? So you're watching a football game, and you see a call on the field, and you're like, oh, no, that was definitely a fumble. That was definitely a touchdown. And that was definitely an inbounds. And so the coach challenges it. This is a hypothesis test exactly. What do we assume is true? You guys, everybody know in sports, if you have even basketball, we assume the original call is true. And the video evidence has to be overwhelming. I mean, what are the words they say? Like in football, they're not going to overturn the call unless it's overwhelming evidence in the other direction. Am I right? Yeah. Now, I don't know about you, but they don't get it right every time. I'm looking at, there's no way the guy caught the ball. There's no way he went out of bounds. There's no way that was a fumble. You're watching this as a fan going, oh, how could they get this wrong? They looked at the video, and it's so close. But so close isn't good. See, the rule of thumb is if it's so close, then whatever the original call was, it's always going to stick. Oh, if the original call was a touchdown and it's so close, it's still a touchdown. If the original call was it's not a touchdown and it's so close, guess what? It's still not a touchdown. We're sticking with the original call unless the evidence is overwhelming, beyond reasonable doubt. Oh, so do they use this in sports? Yes. This is black and white, absolutely the same thing in professional sports, court of law. And if you think about it, it's a very logical approach. Whatever the decision is, for me to overturn that decision, the evidence the other way has to be overwhelming. It can't be just a flippant decision. Nah, I think I'll go the other way. Well, you made this choice. Why would you change that unless you had convincing evidence in the other direction? So in the world of sports, we see this all the time. We'll see a flip-flop in a call because they looked at it. My Kings the other night playing the Ducks. No, that goes. You know, Jonathan Quick had the greatest game I think I've ever seen a goaltender have. I mean, he was all over the map. He thought he was a young man again. He's not. And there was a play where the Kings scored a goal and hits the goalie, and they're big wipeout at the net. And immediately the officials overruled, said no goal, goalie interference, and the Kings challenged. And said, we think you got the call wrong. And so then they, like in football, they go to New York, or the central office. In hockey, they go to Toronto. It took it 3 or 4 minutes, and then the referee comes back and says, good goal. And I thought, no way, I don't think I've ever seen them do that. They overturned it because that means the original call, which they're saying is absolute truth unless we have overwhelming evidence the other way. They're saying the evidence was overwhelming. And to my, happiness that Kings won 2-1 because of that goal. Now, if you're a Ducks fan, you're probably talking, criminal offense here. Yeah. But the point is, it's the same stuff. And I'm trying to relate as much real life as possible so you understand, oh, okay, we do this all the time. So if the null hypothesis is whichever one of these includes the equal, then stating a null we want to be easy. There are only 3 things that we ever actually test, and they're the same 3 things we've been doing confidence intervals for. We test mu, p, sigma. Those are the only 3 things we test. So mu, if I'm making some claim about the average of something, how long my tires last. We have a tire company, we claim our tires last 60,000 miles. Roz had a set of tires, they lasted her 30 and they went bald. You don't believe that claim. So you're a consumer advocate, let's say. So you say, you know what, I want to represent the people. I think this company's making false claims. Does that ever happen in real life?
Yeah.
God, every day of the week. So what do? You test maybe several hundred tires. You test them, you run them on cars. And you find those tires on average lasted, 40,000 miles, but the company's claiming 60. You're like, there's no way. If they're claiming 60, then we should have been a lot closer to 60, but we're really not very close. So you can come out and say, this company is lying. And that company is going to get punished. They're going to get in trouble, right? There are government agencies that protect you from false claims. But what if you go out and you run your evidence and the evidence is really close to 60? And you say, oh, yeah, I guess they can, you're going to quietly go away and not make noise because you don't want to get sued for slander and libel. You're bad mouthing this company that was telling the truth all along. So you got to be careful. But that's kind of how it works in real life. So what I want to do now is how do we set up a null? All right, so let's keep it simple. I'll use these examples. All right. A tire company claims, I'll use the exact example. Their tires last 60,000 miles. Now, 60,000 miles. Now, here's where we got to be a little bit careful. This is in real life. Okay. In real life, most everything is actually an inequality. Oh, can you hang on one second? What you're calling on Carolyn's phone? Oh, okay. Okay. Anyway, I'm in the middle of the process. What's going on? He said he was subbing on Friday. Oh no, he's probably still in bed. Okay. Okay. He just said Friday was going to get back. Give me a minute. I'll call him and see if I post it. Okay. Did they still want him to come in? Okay, I'll try to deal with that. All right. Okay, bye. Sure. It was actually, my wife teaches at a high school, and it was the high school my son was supposed to sub this morning. He's not there. Let's take about a 5-minute break, shall we? I need to. Yeah, but it's the school's in Escondido. Wow. I know he was subbing tomorrow. He was supposed to sub. Yeah, he's an emergency sub. So yeah, let's take a 5-minute break, folks. This is you.
How'd everybody do on the quiz?
Actually, did pretty good.
I gotta see.
Pretty good.
I don't know like the actual percentage, but I got 374 out of 20.
Yeah, I
I was surprised that I was like, what the heck?
I don't think you were stressing over, and I'm like, well, you got
Dude, I was half asleep. I was gone. Like I did not even know what was on the test. Yeah.
I got 320 out of 400.
What's
that?
Like a C?
It's a B.
B? Yeah,
I think
I was happy.
I think anything lower than 300 is like a C.
I was happy. That's what she.
Because I honestly thought I was gonna get like, oh, worse grade than the first exam.
Mhm.
I did that on the first one.
What did you get in the first one?
Oh, I got like a 200 and something out of 400. It
Yeah.
was that.
I like the 185. Yeah.
It was that.
My princess is horrible.
On the first one?
On this one.
I didn't do it. I didn't come.
Yeah, you didn't go down there?
No. I sent an email to Mr. Brown that I wasn't going to be able to come to the exam. They was like, okay, don't worry, but this will be the exam that you're gonna drop. I was like, all right.
Oh, that's cool.
Yeah, it's like I got 400 on both exams.
Oh, that's good.
So I don't wanna look there too.
All the way down?
Yeah.
It's just the way the questions are worded, and subtracting by one was the only real thing, and I think that's.
I'm the best with word problems.
Okay.
So,
Yeah,
I was like,
How'd you do?
I would be. It's something, it's a big thing when like math is like not the hardest class.
It's the hardest for me.
That's
It
funny.
really is.
Well,
When I saw that, I could be.
I mean, it's still hard, don't get me wrong, but
Let me see your word.
Out of all the rest of the classes, yeah.
honestly, I don't think this content is that hard.
No,
It's just,
it's because he's teaching it.
yeah.
Oh, good job.
Well, being a harder use for you gotta memorize
for
everything.
the first exam, I memorized like everything. And then he was like, oh. well, you-
I know, the day of the exam, you send an email, and you can use like so much thing.
Yeah, and then that made it easier, but I think the biggest struggle is the word problem.
Yeah.
Oh, yeah, like understanding what.
Uh-huh.
Because literally, this exam is just word problems.
Like, like this, hypothesis testing, you know, this is a lot saying more than at least.
Yeah, this one's gonna be hard stuff.
But I'm allowed.
Oh, you can.
Give me eight, I'm allowed to, but it doesn't.
It doesn't help.
No, I mean, you'll see, I'll have it there. Anyway.
All right, well, hopefully. I don't know. I called my house and had someone check on him. They said, well, he's not here and his car's not here, so maybe he's on his way. God, I hope he is. Yeah, it's a bad look when you be like this morning, you guys get here, like, where's Mr. Brown? I'm just, taking an extra day.
You don't remember your number by 7:15?
Sure.
It drove me crazy. I got halfway here and I realized I left all my food on the counter. So I had to turn around and go back and get my food because I'm here till after 2. And I don't really have breakfast. So I'm up at 6. That's a little too long for me to go without eating. You got my afternoon class, everyone starts looking like a steak with a head on top of it. I am pretty sure this is how the zombie apocalypse is going to begin. A really hungry teacher just finally lost it. And, hey, students taste pretty good. Okay, a tire company claims their tires last 60,000 miles. So here's something I want everyone to understand. In real life, there are very few equalities. Believe it or not, most everything in real life really is an inequality, even if we don't use the language. For example, Andre's going to go to the store later on today. You have $20 in your pocket. So you're going to go to the store and you're going to buy some items and you get to the check stand and it's $19.50. You say, darn, I can't leave yet because I have $20. I have to spend all of it. Or is it okay to spend less? Is it okay to spend less than 20?
Yeah.
Okay, so you're taking the test at the DMV and you're allowed to miss 6 questions. But you're pretty sure you didn't miss anything. Oh, shoot, I have to miss 6. So you're going to go back and mark some things wrong. Or is it okay to miss less than 6 questions?
It's okay.
You've got on the syllabus, almost every one of your classes says to get an A, you need to get 90%. And Robert got 97%. Sorry, Robert. Wait a minute. Is it okay to do better than 90%? Yeah, I'm giving you examples of things that are absolutely inequalities. These are not equals. No, when you go to the store, you can spend at most $20. You just can't spend more because you only have 20. You can spend less. On the DMV test, you can miss at most 6 questions. In that class, you got to get at least 90%. But we don't use at least and at most all the time when we talk, do we? So when the company claims you're going to get 60,000 miles, what if you get 70? Does that mean they lied? No, what do they say when they say you're going to get 60?
At least.
They're not saying you get at most, because if you get none, hey, we didn't lie. No, they're saying you're going to get 60,000. They don't have to say at least. That's implied that better than they're claiming is always a good thing. Does that make sense? Yes. So if there's certain things, let's say, for example, I'll use track and field, for example. All right. So Lila she's doing the long jump in track and field, and you're in second place at the moment, and you're the last jumper. And the previous jumper jumped, 23 feet, 6 inches. So do you have to jump 23 feet, 7 inches? What if you jump 25 feet? What if you jump 30 feet? All you have to do is jump more than that one. There's not a particular number, it's an inequality. As long as you jump farther than they did, does it matter how much farther? No. So when things like this are stated, sometimes it's not obvious. This isn't an equal versus not equal. This is at least 60. So when we're making our null hypothesis, by the way, this is a claim about the average tire life. Does that make sense? So that means this is a test on mu. There's no probability, there's no standard deviation. That's how long a tire lasts. That would be the average. Oh, okay, that's a mean. That's a mu. So my null hypothesis would be that mu is greater than or equal to 60,000 miles. Okay. If that's not the case, then what must be the case? What's the complement of at least 60,000? What's left? Not more. If you got 70,000, you'd be happy. If you got 100,000, you'd be happy. If you got 30,000, you would not be happy. What's the alternative to greater than or equal? Less than. That's the only thing left. Remember that you got to be everything. So less than 60,000. All numbers are either greater than or equal to 60 or they're less than 60.
Can you repeat that one time thing? I don't know, it just confused me. So.
Say them words. You say them words.
The null hypothesis is that you're going to get at least 60,000 miles. That's what greater than or equal is. I mean, you told me that. So, well, if you're not greater than or equal, then you are less than. And there's no other place to go. If you thought about it like on a number line, you guys remember number lines?
Oh my God.
This is sometimes a visual helps. Greater than or equal to 60 would be this, wouldn't it?
Mhm.
So what's left?
Less than.
Less than 60. Oh, okay. All you want is what's left. So the complement of at least 60,000 would be less than 60,000. Now, what you're going to do at this point, this is later, you're going to go out and collect data now. You're going to go out and sample lots and lots of tires. You're going to do calculations. That's later. You're the statistician. You're the lawyer, if you want to think of it that way. And you're saying, okay, here's the situation. This is what we're testing. They made the following statement. They're either telling the truth or they're not. But if the tires are close to 60, we probably give them credit for telling the truth. If they're way away from 60, then we'd say, no, you can't make that claim.
Mhm.
By the way, can I get away with testing one tire?
No.
No, you're gonna have to be really thorough. Do you know what the most tested and most sued company at the same time is in general?
Most suit too.
Cigarette companies.
Oh.
Really?
Yeah, people are always trying to catch them. Now, everybody knows that cigarettes are bad for you. They cause cancer, tar, nicotine, and all that. But for my entire life, cigarette companies are constantly being sued. And the reason you never win that suit is because you're trying to claim, I got lung cancer because they didn't properly inform me the cigarettes were dangerous. Well, actually, they come with warning labels, and you got to be a knucklehead at this point to say I didn't know. So what it's tested is the actual content of a cigarette. It says exactly how much tar and nicotine is in each cigarette. So a lot of people have been trying to catch them for years on underreporting the dangerous chemicals. No, they don't, because they don't like getting sued. So, but they're putting the right amount of tar and nicotine. This is how much each cigarette has. If they underreport it, they could get in trouble, because now it would seem like they're trying to deceive you. But no, they're actually reporting it correctly. When you're looking at that can of, that doesn't, well, I don't know, maybe it's bad. Yeah, and it says how much of everything is on there. That's probably the truth. It's probably accurate, because there would be no benefit to them to lie in case they got caught. See, it's too easy to catch somebody in a lie when they put everything on the label. That's why it's probably the case that that's correct. Now, what always makes me laugh in that situation is sometimes you look at the sugar content on these things and they're off the charts. Just, I mean, like absurd. You start saying, 30 grams of sugar. But what's even funnier, you got your can of soda and you're going, oh, that's not that bad. It's only got this many grams. But then you look and say 3 servings. You got 1 can of soda. No, I'm pretty sure that's 1 serving. What they'll do is they'll say 3 servings. Each serving only has 30 grams of sugar. Yeah, but that means the can has 90. 90 is like absurd. 90 is like just taking spoonfuls of sugar at that point. That one I think is very deceptive and very, they're not lying to you. But the fact is that's not 3 servings. Would you say that's 1 serving or 3?
I'm sorry.
That's 1 serving. People aren't going to drink that over the course of a week. So they probably should give you everything in that thing now.
How about when they say 0? When they say 0, like
0.
0 sugar, or like when
Oh, I really would avoid that one because that means it's being replaced with chemicals and
is that what it is?
artificial sweeteners are so much worse for you than.
4 grams sugar.
I see 4 grams of sugar. That's not. So anyway, the point is when somebody says something, they're making a claim. They're saying this is the truth. You don't believe it. You're not going to say it's better than what they claim. No, you're going to say it's worse than what they claim. Nobody gets upset if something's better than claimed.
That's true.
That's kind of silly to say if something's better than advertised, I'm going to be upset. No, you're only going to be upset if it's worse because now you're thinking people are getting cheated. That's how it works in real life. That's why I have to know which way an inequality goes. So this is my null and alternative hypothesis. That's it. That's it. So let's do a second one. Okay. Let's say, whoops.
You said null and what's the word you used?
Alternative.
And alternative.
Yeah, it's, you have 2 choices. You have this one and the alternative choice. The language kind of makes sense. All right, so let's say a restaurant says only 2% of customers are unhappy with their meal. We'll keep it really basic, right? They know that they're just saying this because we have thousands and thousands of customers. They go through there and 2%, that's 1 out of 50. If you're a restaurant owner, you could probably live with that. 2% of our customers. By the way, what if it turned out to be less than 2%? Would anybody be upset?
No.
No, it would only be if it was more than 2%, because now you say, no, you're underreporting. If we're talking about people being unhappy, less than 2% would be good. Okay, so now the inequality is going in the other direction, isn't it? So, and by the way, is this a test on P, mu, or sigma? Talking about percentage of customers. Sigma is standard deviation. P is probability. P. Percent is just probability, isn't it? Oh.
Percent is probability, mu is
Average.
average.
And sigma is standard deviation. Now, what is this is not, you're not being clever. There's only one number in the problem. And by the way, you would use 0.02. That's the probability, 2%. There's only one number and that's 0.02, but that's a probability. That's not a mean. I'm not measuring things. I'm just saying happy, yes or no. Happy, yes or no. Did you make the free throw? Yes or no? It's the same thing, isn't it? Think of unhappy as I only made 2% of my free throws. You can think of it that way. That would be really terrible free throw shooting. No, okay. So actually people are like, I missed only 2% of my free throws. That's probably a better way of saying it. So this would be that P, we said 2% or less. So the company claims that they have a pretty good record. By the way, let's suppose you were looking online, a Yelp review or something like that, customer reviews. Are you ever going to see a perfect score for anything? No. So if 5-star, let's say, was a perfect score and you saw somebody was at 4.5 or 4.7 or 4.9, you'd say that's pretty good. Is it even possible, especially if thousands of people are filling this out, is it possible that everybody said it was perfect? No. I mean, you'd say, I think somebody's cheating here, but you'd say, wow, it's overwhelming, how many people loved it. Does that make sense? So I'm saying, hey, only 2% of our customers are dissatisfied with what's going on. You'd say, wow, that's pretty good. Now, it could be that you went out and conducted a sample and it was even less than 2%. You'd say, wow. But if it was way more than 2%, you'd say, In other words, what's the complement of less than or equal? Greater than, because that's all there is left.
How about that's optimal for the HO or that's at most, right? This one.
Less than or equal? At most would be less than or equal.
Oh, okay.
Yeah, but when you're writing the math, you need the inequality though, not the words. That's why I went over the words, because a lot of times we say words, but if we interpret it backwards, okay? For example, let's say for playing weight next season, what is your goal?
Playing weight?
Yeah, playing weight.
290.
290. Is it okay if you're more than 290? Is it okay if you're less than 290? So you have to be exactly 290. Okay, so that would be a case where our null hypothesis would be mu equals 290, and our alternative would be it's not. So what Robert's saying is anything other than 290 would be unacceptable. Higher or lower. That's the third case. I'm going to do that with something else. All right.
Professor, I can see how I could probably get confused when you did the chart of the more than and the at most. Okay, so how again do I, because that symbol on the complement side is at most, but
No,
on the other side,
this is at most.
yes,
So at most means that much or less.
okay,
That much, at
2%
most means,
or less,
yeah, at most is my upper limit, so it's that much or less.
okay,
So what's left? More.
okay,
Remember, if
okay.
one of them has to have the equals, do you agree?
Mhm.
And it's always going to be the null. Well, if that's a less, that's got to be a greater. If that's a greater, that's got to be a less.
Okay,
These cannot go in the same direction because then Roz claims to be above 80%. So if she's not, then she's above 80%. No, wait a minute. It's the same, that's the same thing. Okay. Third example. Now this is kind of what Robert just said, who's equal or not, all right?
The
For a coin to be fair, the probability of tails is 0.5. Do you agree with that? For a coin to be fair, the probability of the tails is 0.5. It can't be 0.55 or 0.37. Right? When they're doing that coin flip before a football game, if you knew it was not a fair coin, wouldn't you always go with the side that lands a higher probability? I mean, if you're smart, that's what you would do. Yeah. So for a coin to be fair, the probability of tails has got to be 0.5. I have a coin. I don't know if it's a fair coin or not. Well, there's two ways I can do this. I can analyze it by, drilling and taking it apart and doing, melt it down and do a weight distribution, spend thousands of dollars trying to analyze this coin. Or I could just flip it a whole bunch of times. Wouldn't that be easier? Just flip it a whole bunch of times? Now, you flip that coin and you notice, it seems to land heads a lot.
There's some certain coins that have a heavier side.
It can be.
But that's
That, by the way, the weight distribution of a coin, do you think it's absolutely perfect? Do you think it's probably not the case, but maybe it's so close that it doesn't matter. But you've been flipping this coin and going, God, it seems like it's tails every time. And then you notice it's, of course, the Harvey Dent coin, right? What's a Harvey Dent coin?
two sides.
It's the same on both sides. You remember Harvey Dent and Batman? He flips the coin, heads, I shoot you, tails, or something like that. Well, it's the same on both sides. So therefore, you're not going to win that one. Let's suppose for a moment that we have a coin. We have really no idea, but you suspect because you just, God, it always seems to land one side more than the other. So you know what? I think this coin may not have a fair weight distribution. Especially, what if this coin was a really old coin? We take the denarii we found when we were walking around Rome and like, a 2,000-year-old coin. I'm pretty sure it's not going to be a 50-50 coin. It's not even going to be round. So how do I do? I tested. I just do it a whole bunch of times. So now our null hypothesis is what? That it is exactly 0.5. I don't want it to be more or less. This is not an at least at most. I want it to be exactly 0.5. So what's my alternative? If it's not exactly 0.5, then it's not exactly 0.5 exactly. Do I care which side of 0.5 it's on? If it fails to be 0.5, does it really matter to me which one? No, it's not a fair point. If let's say we find out it lands tails only 40% of the time and it lands heads 60% of the time, we'd say that's not a fair coin. Oh, but if it was 60-40 in the other direction, it's still not a fair coin. It's got to be exactly 50 in both directions. So you flip the coin 100 times, you got 52 tails and 48 heads. Is that convincing evidence? Or is that, no, that's probably about right.
About right.
Because then the next time I flip it, I only got 47 tails. The next time I got 55 tails. The next time I got 49. Oh, if every time I flip it, I'm pretty close to halfway. Remember the coin, I don't say this jokingly, the coin's not keeping score. Oh, I landed heads last time, so I'm leaning this way this time. I mean, the coin doesn't have a little computer chip calculating how many heads. When you flip a coin a lot of times, we call that the law of large numbers, what I view should be pretty much the probability. So if I flip it a lot of times and it's pretty darn close to 50-50, then I'm saying I believe that's pretty convincing. If I flip it a lot of times and I'm pretty far in one direction, that's where the range rule of thumb came in really handy. Remember the range rule of thumb? Reasonable outcomes. Oh, if I was outside the range rule of thumb when I actually flip my coin, I'd say, I'm suspecting this coin is not fair. So the actual physical testing that we're going to look at next time. Today I want to be able to, first of all, how do we make a claim? How do we actually state a null and an alternative hypothesis? So this is how we do it. So we've done 3 problems so far. 2 were inequalities in each direction, and then this one was just an equal versus not equal. Okay. In most situations where you're testing a mean, it's usually not an equal versus a not equal, because being better than advertised is always okay, right? We're always okay with that. An on-time record for an airline. Okay. If an airline says, on average, we are within, 5 minutes or whatever of when we're supposed to take off. You'd say, okay, I'm good with that. But if they were half an hour late, you'd be upset. Within 5 minutes, so if they were 1 minute late, would you be mad? No, because less than 5 minutes late would be okay, but more than 5 minutes late, you might say that's not okay. So again, the idea when I'm measuring averages, means, rarely is it going to be the mean equals versus the mean not equals. That's rarely going to be the case because again, we'd say being better than advertised is okay. But in a situation like this, no, I need it to be 0.5 or it's not 0.5. It's better. There's no better than. Being not 0.5 would mean it's an unfair point. Okay.
Is it always guaranteed then that whatever the top one is, it's going to be opposite of the bottom?
Yeah, it's the complement. The complement. That's why I went over all the different complements. Well, between the two, we got to cover every possible case. So if it's not every number other than 0.5 is now represented here. When one's an inequality, the other's got to be an inequality in the opposite direction to cover all my cases. That's it. Because otherwise you'd say, well, I got this outcome and it doesn't fall into either category. We have a problem if an outcome doesn't fall into either category. I flipped the coin and I got the probability to be 3. Well, no, it's got to be between 0 and 1. Yeah, I can't have impossible things. So the next thing I want to do is, how do I know when to reject or not reject? Here's the way I want you to think about it. The null hypothesis, like the court of law, is what I'm assuming is true. So I'm assuming not guilty when you're in the court of law. Evidence, we agree, has to be overwhelming for me to change my decision. So what we need to do next is, where is the line in the sand? That's what I like to call it. Where's the line in the sand? So when you cross that line, we can say, nope, it's the other thing. When they're doing the replays in sports, where's that line in the sand where they say, no, this is absolutely convincing in the other direction? Okay. By the way, in a court of law, when we say, Salvador was found not guilty, we're all rejoicing. But are they saying we believe you're innocent? No, we're saying we believe there was not enough there to convince you. There was lack of that. There just wasn't enough there to convince. Okay. In a football game, is there ever a time when it's exonerated? Well, in other words, we don't change the decision. In football, there's 3 things they say. They say, call on the field has been reversed. They do that in hockey, they do that in basketball, they do that in football. That means we found you guilty. The evidence was overwhelming. They say the call stands. We didn't find enough evidence to change the call. You're not guilty. We still could, by the way, you have to understand, we still could have messed up. The call stands. There wasn't enough evidence to overturn it. Does that mean we're saying we're right? No, we're saying there wasn't enough evidence. And then there's the third one. The call on the field has been confirmed. You ever hear him say that? They will say that in sports. The call on the field has been confirmed. They're saying we were absolutely correct the first time. We are innocent. We did not make a mistake. When they say, well, no, they use confirmed a lot of times in sports. We double checked it. It has been confirmed. That means we got the call right. Absolutely, that was the right thing. There's no gray area. There's no doubt in it. We like, by the way, it doesn't even matter what team you liked. When they say it's confirmed, then you go, oh, the referees got it right. They got it completely right on the first try. When they say the call has been overturned, we're happy that, oh, good, they fixed their mistake. But it means there had to have been a mistake first. So we're really not crazy. That means these officials are very flawed, but they at least were honest and they fixed their mistake, or at least somebody else fixed their mistake. But the one that nobody likes is when they say the call stands. We could still be wrong. It was so close it could have gone either way, but the evidence was not convincing in either direction. That's the not guilty, not enough evidence. Does that make sense? That's important. So in a court of law, you were guilty or you were not guilty. But what if it was the extreme that you should have never been tried, be exonerated? That's the rare one. We don't see a lot of that one, but every now and then. So a tire company, you're not happy with it. I hope that's what I'm telling you got there. Okay. There's let's say the tire company, they claim 60,000 miles and you go up and you test them and everything you tested was 70,000 miles. Are you going to make a stink? Are you going to come out publicly and no, you're going to say, wow, these guys are great. They were telling the truth. In fact, they were understating how good they were. Does that happen a lot in real life? Probably not, but would you be okay with that if that happened?
Oh, yeah.
Sure. So the next thing you want to know, I call it the line in the sand. So what would cause me to say the null is not true? Remember, we're always starting by assuming the null is true and the evidence must be overwhelming in the other direction. You with me out so far? So there's three possibilities. And I'll say, let me use mu first of all, just to be easier to start with mu. All right, so my null is that mu is greater than or equal to some number, in which case my alternative would be mu is less than that same number, whatever that number is. That's one case. Second one is that mu is less than or equal to some number, and so then my alternative would be what? It's greater than said number, because that's covering all bases. And the third case, which would be extremely rare for a mean, but this was Robert's weight situation. The mu is exactly equal to a number, and the alternative would be what? Not equal. Everybody okay with that?
Yeah.
So in each case, the alternative is everything else. This is, by the way, when it comes to a mean, like Robert said, no, I have to be exactly 290 pounds. Okay, otherwise something terribly goes wrong with our offensive line will be misbalanced. People will fall in one direction. You know, all the bad things happen. Dogs sleeping with cats, everything. Okay. Do you all agree? These are, when it comes to a mean, these are the only possibilities. I'm saying this is the truth unless this is overwhelming evidence. This is the truth unless this is overwhelming. This is the truth unless this is overwhelming. Okay. So what we always start with is the level of significance. When we say a 95% confidence interval, we say there's 5% in the tail. When we say a 99% confidence interval, we say there's 1% in the tail. The level of significance, okay, that term, we use this all the time. The level of significance is another way of saying the probability that we're actually wrong. Okay, so if I want a tiny tail probability, then that means I want to minimize the chances I'm wrong. So the level of significance is the tail probability. Okay, and we always call it alpha, and we've used that before. That's the tail probability.
I'm sorry, Professor. Level of significance means again?
That's kind of like saying, what's the probability I'm wrong? Remember, when you're doing a sample, you can't have absolute 100% confidence, but you can be 99% confidence. You mean 95% confidence. Those are kind of common ones. Because unless you're willing to sample everything on planet Earth, which is probably not practical, and it might take an eternity, you know. So we'll say things like at the 0.05, that's 5% level, or the 0.01. Those are really the only two you ever use, like in confidence intervals. We'll say at this level. So what does that mean? Well, let me give you a picture. There's three possibilities, okay? So in the first case, we're only going to, and what we say is we reject the null or we fail to reject the null. Rejecting the null means I found you guilty. Failing to reject the null means I found you not guilty. It didn't necessarily say innocent, but you're not guilty at the very least. To reject the null, the evidence has to be overwhelming. So in this case, it has to be overwhelming left tail. Only if it's extremely bad. So Roz claims to be an 80% free throw shooter. She's got to be really, really low before we say she's not an 80% free throw shooter. Because we could just write off to a bad day, you know, if you're close. Now, in this case here, okay, let me erase line on the form. In this case here, we're saying the claim is that the mean is less than or equal to some amount. Maybe the mean has to do with, you know, errors and things. It's got to be really high. So in other words, I've got to be extremely high for me to reject it. I will say this is the truth unless it's overwhelming in this direction. You with me on that? The third one might be the trickiest one. It's equal or it's not equal. Doesn't not equal mean it could be either too big or too small? If it's extreme in either direction, oh, so the not equal, we will reject if it's extreme in either direction. We call the first two tests, very clever name. These two tests are each called one tail tests. Because I'm only going to reject in one tail. You never guess what we call the second one, the last one. Oh, read my mind. This one's called a two-tailed test. Now, I want to go back to think coin flip for a moment. If I have the coin, it is either fair or it's not fair. Do you agree with that statement? There's not a third option. It's kind of almost fair. No, it's fair or it's not fair. What would cause the conclusion of not fair? If it was extreme with too many tails or extreme with not enough tails. Does that make sense? I would say it's not fair in both directions. You with me on that? But most things are only going to be bad in one direction. For example, my tires, you can't be too good. You could only be too bad. Okay. One of them could be the on-time record of the airlines. You can't be too low in terms of lateness, but you can be too high. Darn that airline is on time again. You know, it's sort of like the cable company. They say, we're going to be there at noon today. No, what do they say? We're going to be there between noon today and 3 p.m. Saturday. Now, they give you a window of time that's absurd, and then they still might miss it. The cable company does not say we're going to be there at a time. No, because then they late 100% of the time. They don't do it that way. So they get off the hook of being late. By the way, I have fun with the airlines. Airlines, one of the most important things that airlines are measured, customer satisfaction. Did you have a good flight? Well, how many things can go wrong on your flight? You're sitting there, maybe there's turbulence, but that's not the airplane's fault. You know, that's what would make you angry is if you sat in your plane is an hour late. Most people say, yeah, but my satisfaction is more about on-timeness than anything else. I mean, once I'm physically on the plane, it's a plane. They all kind of feel the same to me, you know, and since they stopped giving out snacks a long time.
Oh, man.
Yeah, well, COVID and stuff and the whole peanut butter peanut allergies too. Yeah.
Oh.
They used to give you the bag of peanuts on
Yeah.
Southwest. Now they don't. Now they give you some pretzel mix that's got salt as the number one ingredient, and then there's something else, you know, crunchy. So an airline measures itself by its on-time record. You understand? So do you know what airlines do? It's really funny. Okay, let's say you're flying to, I'll use Sacramento as an example, because I've flown there many times. That's almost exactly a 1 hour flight. So what does it say? It says you're going to take off at 8 o'clock and you're going to land at 9:30, but it's only an hour long flight. Yeah. My daughter lives in Portland. She flies back and forth 2 or 3 times a year. It's 2 hours and 10 minutes. So what do? They say it's 2 hours and 40 minutes. That way, if the plane's a half an hour late taking off, it's still landing on time. Is that deceptive? Is that cheating? Oh, it is so cheating.
Yes.
If you ever look at your thing, they cushion, they'll add 20 or 30 minutes to the flight time that you know it doesn't take that long. So that way, see, it's not when they leave, it's when they land they measure on time. Not when they leave, it's the landing. Now, what if they actually do leave right when they're supposed to leave? Because what I do when I pick up people at the airport, I'm one of these crazy people. I actually check flight status after
Yeah.
the flight takes off,
Oh.
and they'll give you to the minute when the flight's going to land. And if it's a long flight, I'll check maybe every hour. And that way I'm not hanging around the airport, for 2 hours waiting for your flight. And if your flight's delayed, I know. So that flight that was supposed to leave at 8 and land at 9:30, it left at 8, and then we'll say, arriving estimated time, 9:01, 9:02. It'll now give the correct landing time, which will be way earlier than the ticket actually says, because they left on time. Isn't that crazy? So an airline is measured on its on-time. Nobody complains if it's less late. They only complain that it's more. That's why it's a one-tailed test with an airline. With your tires, nobody's going to complain if you get too many miles on your tire, only if you get too few. That's why most tests are one-tailed tests. Because again, too good is never a bad thing. But when I'm testing things like a coin flip or Robert's weight, it's 290 or it's not 290. That's a two-tailed test because it's equal or it's not equal. And not equal means I will reject in either extreme. So here's what we do. I want you to understand then the lines on the sand. You're going to do a calculation. You're going to, in each of these cases, for all the mu's and all the p's, the only calculation you do is a z-score. You're going to calculate a z-score in each case. And if the z-score is extreme, that's typically when we think, we're going to reject. It was too far away. And I don't mean on the good side. It was too far away on the bad side. So the question is, what would cause me to reject? Okay, so in a one-tailed test, we don't use the same numbers we used in the confidence intervals. Now I brought, and you guys have the magic numbers. And by the way, I printed all these last tests, but nobody took them. I've got all the formulas. So it's 3 pages of formulas now. Do you have them in front of you? Or? Oh, you have all of them. You have them all? Yeah, I want to make reference to this because the next thing we're going to do is not a compilation. We're just looking something up. And we sometimes forget the difference. Calculate, if I need my calculator, if I can just look something up. And have it?
Yeah.
Okay. Yeah, you have 3 pages. You have 3. Okay, so far we've used 3 pages. You have all 3? Okay. There's actually more, but as the course is going on, we're starting to drift into new pages. So I want you to go to the common values. Remember, I call those the magic numbers. And you would be wise, probably at this point, to take a highlighter. It's right in the middle of the page. What page is it? The second page? Second page. It's right in the middle of the second page. These guys.
Okay.
Those are the magic numbers. Those are numbers we looked up that are computer generated numbers. They give us the probability that a z-score is in this range. Now, when we did a confidence interval, the confidence interval technically, see my picture? A confidence interval is the meat. Oh, so if I did a 95% confidence interval, that meant 2.5% was in each tail, and the meat was here. So we looked up the z-score that corresponded with a 2.5% tail. But what if I want to do 95% confidence, or then there's a 5% tail, but I only have one tail? I'm not going to use the same number, am I? The 1.96, that was the z-score that went with a 2.5% tail, and we used it at both ends. But what if I want all of the 5% in one tail? Oh, that's z with a 0.05. What is that number?
1.61.
That's not the same number. So there were 2 numbers that you didn't use very often. You've been using the 1.96, that's the most common one, that's confidence interval. You was using the 2.576, that's for 2.5% tails. That was the 99% confidence interval, and you use those over and over and over again. But now when we're doing testing and it's only one tail, I'm not going to use either one of those numbers. I'm going to use the ones that correspond with 1% and 5% all in one tail. So you said one of them was 1.645. What's the other one?
326.
Exactly. I don't need you to memorize these. I need you to just simply use the correct one in the correct situation. So the common notation we often use, you're going to calculate a z-score. Okay. And that z-score you're going to compare to something. You're going to compare it to your magic number, let's say. Okay. It's either bigger than or smaller than. It's actually that simple. So let's say we want to do alpha equals 0.01. In words, that means 1% level of significance. That's what that means. That means that I want to be, no matter what happens, I am 99% certain that I'm correct. Or another way of saying it, if we just sampled over and over and over and over again and got every sample good and bad, 99% of the time we're going to make the right conclusion. That's another way of thinking about that. Can you ever have 100% certainty? Not really, because you're doing sampling. 99% is pretty darn good, by the way. If this was a court of law, I think 99% would be beyond reasonable doubt. I think, you know, I am so confident that we didn't mess that up. It's a safe way of viewing things. If I said I want a 1% level of significance, then what would cause me to reject? Well, first of all, because it's a left tail, wouldn't it be a negative z-score? Because it's in the left. So we would, and in words, we would reject if the calculated value of z, and just to make it easier to conceptualize, I like to say z star. It's the calculated z. It's not a z I'm looking up. If my calculated value, and what would you calculate? Well, you'd have your sample. So you had all of your sample information, you calculated a z value. If z value was more negative than what number? Robert, you just said it? Negative 2.326. But you notice it's got to be negative. You're to the left of the negative. What about this one? Same thing, 1% level, but now I'm going to reject in the far right. So now what am I going to reject for problem 2 or for picture 2? I will reject, this is the middle one, if my calculated value of z is too big. So greater than positive 2.326. Yeah, that's, by the way, I'm a big picture fan. You guys know that by now. By sketching the little simple picture and saying, which end am I working with? Because I'm going to reject in the extreme left, that's the picture, oh, smaller than a negative. In this case, I'm going to reject in the extreme right, bigger than some positive number. I'm still at the 1% level. Now I'm doing my coin flip. So now what will I reject at? This one's a little trickier. Because it's two tails, now they're both going to be 0.5%. So this one I'm going to reject. Whoops. I'm going to reject if z star is too small or z star is too big. So now what would too small be? Now you're using the 0.5%. So you're not using the 2.326 anymore. Which one are you using?
1.645.
No, the biggest one, 0.5%.
Oh,
You're using 5%. So what's the 0.5%? That's this one. 0.05. 2.576. So I'm going to reject if I'm smaller than the negative or bigger than the positive. Because in this case, the total tail probability was 1%, 0.5% in each tail. And the 2.576 we were used to using for confidence intervals. So in a two-tailed test, which is the last one, you use the same z's you use in a confidence interval, both ends. But most of the time, hypothesis testing, most of the time it's going to be one tail. Again, because you can't be too good. Right? I always have to remind people, you can't be too good, you can only be too bad. You know, did your parents ever get upset at you because you were too good? Probably not. Yeah. Did your teachers ever get upset because your test score was too good? Probably not. We have fun with that one, but yeah, usually it's one direction or the other. Okay. So far so good? All right, so. Let's do, heck, I'm gonna bring this up. I'm gonna work on a few of these right now. There is no calculating whatsoever today. Today is just stating what our hypotheses are and what would cause rejection. Now, that was 0.1. The only other one you'll ever use is 0.05. If I use 0.05, then I'm going to use different numbers on it. Now, there was a question on the exam. I'm going to give the exams back in a minute. It's my favorite question. I ask this question every semester, and sometimes people get it. The question was, oops. Last month, 10,000 people applied for a position with the San Francisco 49ers.
Oh,
The company decided to hire the top 1% of applicants. By the way, this is not uncommon. I know, for example, the fire department in San Diego, because I had a friend who applied many times and he didn't get it. You actually have to take a standardized test. There's a whole bunch of things. And they only call you back if you were in the top 1%, regardless of how many applicants there were, because they really want the elite. And he always did well, but he would never quite crack that top 1%. So he never could get that job for a long time. But they're going to hire the top 1%. Well, how do they know what that is? Well, if the scores are normally distributed, then you know what the Z-score is that you're looking for. So top 1%. What's top 1%? Whoops, sorry. In this picture, isn't that the top 1%? That's who we're hiring. If your Z-score is bigger than 2.326, we're going to hire you. Oh, okay. So if we know this already. We know that Z is score minus mean over sigma. So if I multiply, that means Z times sigma is score minus mean. So therefore, score equals mean plus Z times sigma. And some of you actually did this. If I know this, this, and this, then I can tell you the score. Do you agree? So what do we know in this problem? We know the mean was 32.7. And we know sigma was 7.01. And the Z I'm going to use was the 2.326. Now, you can only have integer scores. In other words, think of it this way, just how many right answers did you get? Keep it simple. You can't get 9.7 right answers, can you? All right, so we're going to do this calculation. Some of you got really close to this. You may have used the wrong Z-score or simply copied one of the numbers incorrectly. I think somebody got really close. A couple of you actually got some portion of credit on that one because you have the right idea. So let's calculate this. So in this problem, what's that going to be? It's going to be 32.7 plus 2.326 times 7.01. Can you guys calculate that for me? This is the minimum score required to be hired by the San Francisco 49ers to work for their front office or whatever. Okay. I ask this question every semester. I like this.
49.00.
So what score do they need to get? 49? You got to admit, that's a good question. What's the minimum score they have to get to work for the 49ers? Is it 49?
Pretty good.
I think Lila, you got really close. I think Andrew, you also got really close on that one. Yeah, probably. Well, I think you used the wrong mu. I think you used that. So you copied it wrong. But do you have any idea how hard it was to work backwards to make the numbers come out to be basically exactly 40? So I always have fun with that question. So if you looked at the key, I think it says 49. Duh. Like to work for oh, by the way, I could ask a similar question. You want to work for the Philadelphia 76ers. I would probably design the question so you have to score, 76. Yeah, that makes it way more fun, doesn't it? Now, there's no way you could have known that was the answer. That's not possible. That's not the point. It's the fact that we did the calculation correctly. And by the way, we've done this calculation before. This was the warranty question. Remember, what would you have to do if you want your warranty to catch the worst 1, 5, 10%, whatever? You did the exact same thing. You started with the mu, the sigma, and the z-score, and you figured out what x had to be. So you have answered that question before. This thing is giving me nothing but issues. Hold on. I had it all set up. There we go. Man. All right. What I want to do is I want to do some of these problems from the newest quiz. You guys always like it when we do that.
Yes.
Part of me, I don't do that to pad your score or do anything like that. I do it because it's fresh in your mind.
Yes.
And the mistake a lot of people make, and I have calculus students all the time and say, is there a best way to prepare? And I say, well, one of the things is when it comes to things like homework and stuff, don't wait to start it. Because if, let's just say whatever we do today made perfect sense to you. So you, on Monday night, you're going to sit down and start the homework. That's 4.5 days from now. It's all gone, isn't it? In fact, by tomorrow, it might be all gone. So the mistake, a lot of times we wait too long, and especially we don't take great notes. We wait too long to start something and then it's gone. And it almost feels like you have to start all over.
Yeah.
That's one of the reasons I'd rather hit this now. I don't need you to finish it now. I need you to attack it right now. Give me just a moment. It's not being particularly fast today. Yeah, my computer at home is old and slow, and it looks like it's light speed compared to this one. I should probably do that. I have one of my classes, one of the other rooms, it is, I go like this. Yesterday, they counted, they were having fun. 1, 2, I think they got up to like 60 before it finally got. It just won't catch. There was one day it wouldn't catch, and one of the students came up and just sort of laid down and hung on this because I was trying to do stuff. And yeah, we have a bazillion-dollar building with crappy equipment. All right, so we want to form the null and alternative. So the very first thing you notice is, okay, I'm going to have H0 is the following, H1 is the following. What am I testing them? So there's only 3 things you test: mu, p, sigma. What am I testing on the first problem?
Probability.
So mu, p, or sigma?
P.
P. How about the second one? Mu. How about the third one? Half the students, 50% of the students. Probability, good. If I said half the people are doing this, half is 50%. Oh, that's a probability, isn't it? Isn't that subtle? We use everyday language. We want to keep, how about the last one? The standard deviation of human body temperature is exactly 0.24. Sigma? That's kind of easy. By the way, this is actually, I don't say a scientific fact. This is what science uses as fact. I mean, could it change? All your life, what have you been told the average human body temperature is? All your life. 98.6. Have you heard that your whole life? 98.6? They stopped teaching that a long time ago, by the way.
Oh, wow.
I think I saw in the stats book recently, it's now 98.3 or something, which I laugh. I only reach 98 if I have a fever. My body temperature never measures 90. I'm always 97 point something, which is weird because if you have the night vision, military night vision goggles, and you look at me, I'm the red glowing object. I mean, I generate heat.
Wow.
When my kids were young, if they sat on my lap for more than 5 minutes, they were out cold. It was hysterical. I generate heat. I sleep on top of the bed at night where my wife's got layers and layers and layers. I'm never cold. I literally am never cold. Yet my body temperature is well below what's average. So I guess I heard rumors that my grandpa was a lizard or a reptile of some form. Yeah, I think I'm part reptile because reptiles are cold-blooded. My body temperature is, now the reason I'm pointing that out is my body temperature is at least 2 standard deviations from the norm. I am an extreme when it comes to body temperature. So the whole, every time you did anything during COVID, they'd always want you to do your body temperature first. And my wife had the swiping, we have the one that swipes, which I hate. 97.0 is about the highest it measured. So then you go to the doctor's office, and now that you go to like the dentist, and they hold one close to your head. They don't even swipe it. And they did it, she did it like 3 times and it kept coming out like 93 and 94. And she's like, well, I go, no, it's probably not accurate. I said, well, so why? I said, well, I'd be dead. You can't have a body temperature of 93 now, you'd be dead. Hypothermia hit and you died quite a while ago. I don't trust any measuring device, but I do know my temperature is always in the 97s when it's measured, and occasionally even in the 96s, which is weird. I think that's just a flaw in the measuring. To be below 97 makes me more than 3 standard deviations. I'm now like 1 in a million. But I point that out because this is actually a real number. Now, you don't believe it. You go out and conduct a hypothesis test. You grab many, many people and you simply take their temperatures. But you're not looking at their average temperature. You calculate their means so you can calculate the standard deviation. How spread out are they? That's how you would do the test. You'd measure against the standard deviation. Now, what if you were also testing the mean body temperature? Oh, okay, then you could also do a test with the mean. Wouldn't that be great? Kill 2 birds with 1 stone. So what I want to do in each of these 4 cases is write H0 and H1. And there's only one thing that's, so what we agreed on, this test was on T, this was on mu, this was back to P, this was to sigma. What are you going to start by saying, this is the truth, that's your null hypothesis. The alternative is, if the evidence is overwhelming, I will switch over, right? If video evidence is overwhelming and we overturn the call on the ice, it's a good goal, then Mr. Brown's very happy, okay? No, so how
Check
it's
if the first one's correct.
now in this
That's
case,
right.
in this case, this is an equal versus not equal because we're saying this is the probability. This isn't Roz says I'm 83, so better's okay. This is just here's an easier way to think about this.
Okay.
I'll use the Lakers because that's the only team I actually pay attention to. The Lakers this year as a free throw were like, let's say something like 72% as a team. So you're saying the Lakers probability of free throw is 0.72. Now, it could be you're going on old information. Maybe that number has changed.
Okay.
So you're going to say it's either that number or it's not. Now it's not a question of better or worse because they're saying we're really good. They're just saying I'm measuring this. This is more like the coin flip.
Okay.
I'm measuring, is it 0.83 or is it not 0.83?
Okay. So it's.
Do you notice I
Equal or not?
yes, do you notice I bolded the is?
You did.
Just to make it, oh, I'm not saying that I see what you're saying. I'm saying that this might be like the team's percentages, and you're saying, okay. One of the ones I used to love using with the binomial probabilities, P and Q. I didn't in this class because I will be now, but I used to use Kobe Bryant. I'd say Kobe Bryant's career, and by the way, how do I know? I just go to ESPN.com, I look up Kobe Bryant, I look at his career free throw, and gives me the exact decimal. I'd say the probability Kobe Bryant would make a free throw is 0.8562, something like that. Now, if he shoots 10 free throws, what's the probability he makes at least 8? He makes 8, 9, or 10 using that binomial probability. You can calculate and tell me exactly what it is. And do people use this in real life? Oh, yes, sports gambling. Sports gambling is always based on the probabilities of things. Oh. So that's just an is or it's not.
Oh, okay.
Perfect, perfect. It's an is or it is not. Now, which one is the is, the null or the alternative? No, and then the alternative is it's not. Yeah, perfect, perfect. Okay, now the next one. By the way, this says there's no way it can misinterpret. That's at least. Which direction of the inequality is at least? At least means that much or more, that much or less, which is it? At least. You got to bring me at least 10 cookies to make me happy. So error on the side of 20, that'd be okay. But 5, oh, that won't cut it. So at least is what? That much or 4. So which inequality is at least? Less than or equal, greater than or equal, which one? Because you have to change it to an inequality, not words.
Oh,
Greater than or equal. More is good. With at least, more is okay. Less is bad. So if you got to get at least 90% in order to get an A, then less than 90% would be bad.
okay.
So more than 90% will be fine. Now, what are you testing? Which variable? Mu. And that, by the way, it doesn't matter which one you put down in the scale. Mu is at least, mu is less. Perfect. Now, the next one, I used different language. So this is one of these, we use words like this all the time. You know, half the people think this way, or 2/3 of the people think this way, you know, 60% of the people think this way. That's the test on the team. You're not measuring something. Is basically I walked up and said, Robert, do you recycle? Yes or no? That's the question. It's not, I'm measuring, it's not a degree. So I counted the yeses and I found out, oh, half of all the people recycle. But Salvador's saying, no, you're doing on my student. No, I don't think that's accurate. Okay. But that says at most half. So what inequality is at most? That's what you just said about at least. At most means, is that the upper limit or the lower limit? At most means that much, or you can miss at most 6 questions on that driving test. Oh, so when we say at most, we're saying that much or less.
So, why don't we do that
I'm trying to help you.
Was that hard?
No.
No. It's translating the words that is really, really important.
Would it be this one?
Which one are they? What is students? You need a number.
Oh, for this one. Oh, okay.
Yeah. Yeah, that's
Yeah,
half.
yeah.
Again, you guys don't speak with decimals. You know, so today, Roz, you go home and your husband has a foot-long sandwich. Oh, can I have 0.5 of that sandwich? You would all say that, right?
No,
No, would you say I want the sandwich divided by 2?
no.
You say, give me half the sandwich. Come on.
Yes.
Yeah, so language is very important, but we have to go back and forth. I have fun. Nobody speaks in decimals. Right? So I half is 0.5. Now, the last one we said is a test on standard deviation. So it's test on sigma. So here's what we're really saying. It's not about, well, it's at least that or it's at most that. You'll higher or lower is okay. No, we're doing a measurement and we're reporting. Think of this like science. You know, it's like law of gravity, you know, speed of light. It's a numerical value that we're using to represent human beings. I don't want an inequality. I want it exactly right. Kind of like when we say the average temperature. For years, we always said 98.6. Now that number has been lowered. Like I said, the last time I saw it, I think I saw 98.3. That is now the universally accepted average human temperature.
That's the equal.
So this would be the equal versus the not equal. Does that make sense?
Mhm.
And that's important that we interpreted it correctly, because if it's equal versus not equal, then I will reject in either extreme.
Okay.
You guys good with that? Okay, now the second part is line in the sand stuff. Come on, scroll. It's not scrolling. There we go. All right. So this time, I'm telling you the null and alternative. This is a new set of questions. I'm telling you the null and alternative, okay? And the first one is, the null is that the mu is less than or equal to 75. The alternative is it's greater than 75. And then I'm giving you the alpha on the left side, which means you have to look up the correct line in the sand. It's one of those 4 numbers. And are you going to reject if it's on the left end, which means it's less than a negative number, or are you going to reject on the right end, which is bigger than a positive number? That's what we did a little while ago. So this one here takes a little bit more. There's no calculating. I look up one number. Now, does it matter whether it's one tail or two tail? Yes. That's one tail. That's one tail. That's two tail. Equal versus not equal. I reject in either end. How about this one? Two-tailed, I reject at either end. That's why in those two, I have to cut the alpha in half because I'm going to reject at either end. Does that make sense? So look at what we just did. It's the stuff on the other side of the board here, by the way.
We did the Z, and the stars.
Yeah, so let's just do the first one.
Okay.
Okay, it's a one-tailed test, so what's the magic number I'm going to use? There's only one value you can use. Which one has it? All 5% in one tail?
1.645.
Beautiful. It's 1.645. That's my magic number. Now, the second thing which I would strongly urge you to do, you never have to, but even in my calculus classes, I tell people, you want to draw a picture. It helps you so much for interpretation. So I'm going to reject when? When it's really, really big. So what am I going to reject?
Over there, okay?
So we say it like this, reject. And by the way, you don't have to state what the null hypothesis is, just say reject that because you've already stated it. You don't have to keep rewriting it. Reject the null if my measured value of Z is, first of all, bigger than or smaller than? I want it in that direction. So I want it bigger than, what number, Robert?
1.645.
That's it. There's nothing else for you to do. That is a perfect answer.
Oh,
Now, here's what's missing, the data. We're going to go out, collect a sample. We're going to calculate our Z. If our Z is bigger than this, then we say we reject the null hypothesis. We avoid saying things like you were lying to us. No, we reject the null hypothesis.
So that's how you would answer that question?
Well, we're going to reject the null if this is true. Based on this, based on that situation. Now, what would actually, how do you know if you're rejecting? Well, you actually got to go out now and have the data and calculate your Z, but that's easy. That's next class. Today, I want to just, with the criteria for accepting or rejecting, or how do I actually state the problem? No calculating today.
Okay. So my
This is so necessary before we start actually answering real questions.
criteria is all.
Because it's sort of like saying, we're going to try somebody in a court of law, but in the end, we're not really sure what it's going to take to come up with a conclusion of guilty versus not guilty. No, we kind of need to know, this trial could take forever if we don't actually have a, an end in mind.
my question is for number 5, that's when you would respond to that question?
Yeah.
Okay.
Now, question 6 is real similar, but notice my inequality now is in the opposite direction. So what's going to cause me to reject now?
Reject is
If left or right tail?
left.
Left. So now it's going to be extreme negative number. Because left tails are negative numbers, right tails are positive numbers. Because remember, you're talking about Z-squares. And by the way, what magic number am I going to use for this one? One tail, 1%. So that means all 1% is in the one tail. So what's the magic number? Everyone should be looking at that.
2.3.
2.326. Exactly. But now in the second question, and this is why I always draw a picture. Do you agree that this is going to cause rejection? If it's extreme to the left. Rejection comes from the alternative. What's going to cause you to reject? In the first one, if it was extremely big, extremely left.
Oh, yes. Okay.
Oh, okay. So now I need, if I what? Am less than, but if I'm in the left tail, that's a negative Z value, isn't it? Which Z value is it? You said it.
2.326.
But be careful. Do you know why I got to say negative?
No.
If you say less than, where's positive 2.326? That's why.
Okay.
If you said, I'm going to reject if it's smaller than this, do you realize you'll reject 99% of all outcomes? I only want to reject 1% of all outcomes. So the positive, the negative, the greater than, the less than, that is life and death. If I make the wrong conclusion, you can do everything right from a mathematical standpoint, but if you make the wrong conclusion, that's considered bad. You're making a business decision and you make the wrong conclusion, then your business might go under, right? You make the wrong investment. I did everything right, but I just simply went in the wrong direction because I was not paying attention. So there's inequalities and there's signs that have to go.
So for number 7, you're looking up the common Z value, it would be 1.645.
Except in this case, it's a two tail.
Mhm.
Oh, so now I cut it in half. I cut that in half.
So it'll be
So 005.
0.005,
So which one is 005?
this one.
No, that's 05. 005.
Okay.
So think of it this way, Roz. This is very much like the 99% confidence interval. This is very much like the 95% confidence interval.
Okay.
Why? Because it's two-tailed. So from the standpoint of setting it up, two-tail is more writing because I'm going to reject big or extreme, but the Z values I use are the more common ones. Oh, okay. I'm going to use the 196 and the 2.576 because it's two tails now.
I see.
So do you notice in these four questions, in each one you use the different magic number?
Uh-huh. I do.
Do you guys want to think?
Yeah, oh, yeah, I didn't have the.
We're having a party here. Let me do that now because we're really, I know we're running a little overtime, but we're having fun. Right?
Okay, I got it. Thank you.
Yeah, the glass. Thank you.
That is our primary goal in this class, isn't it?
I was so proud of it.
While we're at it.
Oh my God, it's an
You had
8.
trouble on the first page. Yeah.
Yeah, I thought so.
Subtracting them backwards and little things like that. That's one, you've got to solidify that though, because those are mistakes you can't afford. Oh, that's an easy one.
Yes, yes. That was a big test. I was so proud.
Did you ever see that?
Oh.
This is the best I've done.
George McFly, like, you are my density. That is like one of the greatest movie lines ever. All righty. Yeah, you guys have seen Back to the Future, right?
Yeah.
You know that line? Because Michael J. Fox is telling him, she's your destiny. And so you are my density. My youngest daughter had a close friend named Destiny, and I would always say the same thing. I'd always call her density. But no, you always got to say, you are my density. And like, you've never heard that one before. It's like every day of my life, Lines like that, you got to keep repeating because they're so great. All right, you guys good on this? There's nothing about this is hard. This is new. You've never seen anything like this before. Oh my goodness. Turning over a new leaf. All right, I will go ahead and start the recording now.